Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to this fifth lecture of Module 8 on rock load and support system. In previous lectures we have elaborated about empirical and semi-empirical approach, structural defect approach or block theory, and rock support interaction approach for estimation of rock load or ground pressure. Now in these lectures we will integrate all the previously discussed approach for the same. In addition to this, we will also learn about support system with a special emphasis on mechanics behind the working of rock bolts in brief. In this lecture, we are going to discuss about unified approach, support system and mechanics behind the rock bolting or the work of rock bolts. Regarding this, we are going to cover about introduction, structural defect support in association with rock support approach for integration in form of unified approach. Friends, unified approach as indicate the integration of all the previously discussed approach for determination of rock load or ground pressure. However, this concept disregarding the empirical and semi-empirical approach or semi-theoretical approach, this concept is integrating about structural defect approach or block theory and rock support interaction approach in detail for development of a concept under the heading unified approach. Friends, as you know, the ground is made up of different discontinuities and others. As for structural defects, we have discussed there is a formation of blocks due to intersection of the joints along with the surface of opening, or due to intersection of different joints, formation of this type of blocks, and the movement of block is responsible for deformation of whole ground, resulting failure of developed structure, existing structure and underground space. This unified approach suggests more generalized form, and in this generalized form we are going to apply this structural defect approach and rock support interaction approach. Regarding this, as per the concept of unified approach, it is proposed that there is a formation of three zones. Plastic zone, the loosening zone due to structural defect can occur about the opening. Here the formation of zone due to structural defect formed by intersection of joints along with the surface of this opening. Then along this there is a formation of loosening zone and formation of plastic zone and formation of some partially affected zone, etc. About the opening, the condition for the appearance of such zones are the zones due to structural defects can occur when the rock strata has one joint set or more joint set, at least one of which delights on the surface of opening. Otherwise, this concept is not going to accept the distribution of joint which is diverse in nature and not going to intersect each other and not exposed on the surface. The loosening zone can occur when the initial in situ stress ratio and the geometry of effective opening shape defined by the geometrical orientation of structural defect that formed by intersection of joint and surface of opening are such that the tensile stress region about the opening are to occur. The loosening zone is associated with the zone caused by tensile stresses which the rock mass cannot sustain and become free from the two ground space filled about the opening. Friends, we know that the tensile strength of the rock mass is very less in comparison to compressive and shear strength of rock mass or rock. In case of the tensile stress, in normal condition the rock is going to show a reduction of strength average 1 by earth of compressive strength. If compressive strength is 1, then the tensile strength should be 1 by earth. The plastic zone can occur if the redistribution stress state in such a that it is sufficient to cause the yielding of rock in the region outside the possible above loosening zone. Here we can see when we are going to create this opening, then due to presence of these structural defects caused by joint J1 and J2, J1, there is a formation of block due to this structural defect concept. Due to movement of this block toward the opening or inside the opening or into the opening, then there is a loosening of strata as per structural defect approach we have already discussed. When this block is going to move, then the another block lying here above is going to take the place of this movement induced open spaces. Similarly here, so due to movement of these blocks there is a formation of loosening zone. So as per this concept, above this structural defect approach, so this is the zone due to structural defect. Above this structural defect there is a formation of loosening zone, and this loosening zone occurs and under the influence of tensile stresses, and this opening of this loosening zone is going to influence the zones lying above this loosening zone and resulting plastic flow zone. This is the plastic flow zone. This plastic flow zone lying above the loosening zone, and loosening zone covering the structural defect form zone. And this plastic zone, due to plastic flow zone, there is induced effect, and this induced effect is going to create plastic hardening zone. It means as per unified approach we can say that the unified approach is responsible for formation of zones, namely structural defect zone, loosening zone, plastic flow zone and plastic hardening zone. With help of simple stress strain curve, if we are going to see at initial stage of creation of this opening, the strata or the rock present in ground is behaving elastically up to certain level, and the behavior of strata is safe without failure. Then after this there is a formation of loosening zone after reaching the shielding, and then formation of this plasticide zone. This plasticide zone consisting of two zones, one is the plastic flow zone and another is plastic hardening zone. Then after reaching this plastic hardening, the strata is unable to sustain with effective applied stress and going to show failure. If this type of opening subjected to under confinement are subjected to sigma 1 and sigma 3, means under triaxial stress condition, practically biaxial, but we are considering triaxial for explanation. In triaxial stress condition, then after excavation induced stresses resulting the movement of blocks formed by intersection of joints or discontinuity. Due to movement of this type of block toward the center of opening, there is a formation of loosening zone. This loosening zone is under influence of tensile stresses. And after the formation of loosening zone, then there is still induced effect that are responsible for formation of plastic flow zone. And this plastic flow zone induced effect in overlying surrounding strata, surrounding mass, then there is a development of the plastic hardening zone. After plastic hardening zone, there is no influence due to creation of this opening, and this remaining strata is remain in elastic in nature. It means this unified approach is principally based on the concept of elasticity, brittle plasticity, and different state of plastic. So, as per this unified approach, we can say that this rock strata or rock mass present in ground, influenced by creation of underground opening, is behaving elastically, no zone. Then about the plastic hardening zone, then plastic flow zone from the upper side, and then loosening zone, and then structural defect zone. In this way, the ground is going to provide the support pressure on the support system. If the support system is able to sustain, then we are going to protect opening, otherwise we are going to see the result about the failure of opening. As far as support system is concerned, to protect such type of created opening, where we have already calculated rock load or ground pressure through different approaches: empirical approach, semi-empirical approach, structural defect approach, rock support interaction approach, and finally integrated approach, mainly involving the structural defect approach and rock support interaction approach following the Mohr-Coulomb's criteria under the rock support interaction. To counter this type of rock load or ground pressure coming on the roof and the walls of the created opening, we are going to utilize support system, and we have some support system. Although we have varieties of support system starting from the timber to the steel girders to the wire mesh to simple concrete support, brick support, masonry support. Then in case of underground opening, in major cases or commonly we are utilizing about the support system or the support members. The support member principally we are using steel ribs, steel liners, concrete liners, shotcrete, rock bolts, and others also, wire mesh, masonry support, girders, timber support, etc. But nowadays we are going to stand-up time that varies from rock to rock or from ground to ground. It may be 0 for the running ground in soil and sand. It may be several years for squeezing ground condition, or several months in case of squeezing ground condition, or finally in squeezing ground condition sometimes we are going to close the project even. The support system uses steel liner plate sections against the soil and bolted ground to provide extra supports. Rock bolts are very simple, cheap and easy in installation, widely utilized as a support system in varieties of underground structure and surface structure also. It transfers the load from the unstable interior to the stable zone and enhancing the strength of the damaged rock. Shotcrating. The shotcrete is the mortar or concrete. It is a mixture of fine sand, cement and water as a mortar, or aggregate cement and water as a concrete. The quick setting concrete is spread into the bare rock immediately after excavation and commonly used as the primary supports in the tunnel, not a final support. Rock anchors is steel reefs of steel rods of the extended length more than the bolt and utilized for supporting by inserting such type of steel rod in holes and fixing in stable zone to bear the load of the damage zone and provide support to created opening. However, chain link fabrics are also utilized, that is the short crating done followed by the steel mesh followed by short crating against and so on. Beside this we have other type of support system, and now in technology we are day by day improving the support system for different type of ground condition, particularly in view of squeezing and swelling ground, where we are going to see continuous increment in rock load. Friends, you can see some of the view of the steel reefs are small chips type of fillings going to put and then going to spray concrete and cement. Here you can see the view of the steel reefs. This is the view of the rock bolt, and this is about the short crate taken from website. You can see the source. Friends, regarding the rock bolts, how the rock bolts is working to support created underground opening. Here we are going to describe in brief for calculation of the number of bolts and length of the bolt. You see here the number of rock bolts we are going to insert in under the confinement, where this sigma 1 maximum principal stress and minimum principal stress distributed around this strata. If this rod is making some angle alpha, assume that it is going to make some angle alpha where the normal to this zone is a theta, then we are going to calculate the bolt crossing the plane alpha, the axial component sigma A and shear component tau S are related to the stresses developed in bolt, and this sigma B is representing the stress developed in bolt. In this way we can calculate here axial component sigma A is a sigma B cos alpha, where the tau S shear component tau B sin alpha. Following the concept given by Mohr-Coulomb's criteria, we know that the shear strength of any system is a simply cohesive strength, normal stress and the angle of internal friction as a tangent. The strength developed in bolt, B for bolt, of the bar at yielding can be calculated by the one Mises criteria, representing here the stresses developed in bolt is equal to the sigma B is equal to sigma T by under root sin square theta plus 3 cos square theta. One thing I try to explain here, the maximum stress developed in bolt, when this maximum stress is developed in bolt, and where we are going to see if we are going to put theta is equal to 90, then this value of sigma B we are getting maximum, can bear the maximum stress, and if we are going to put this 0 value, then sigma B we are going to get minimum. Therefore generally we are going to insert the bolt perpendicular to the discontinuity. Here this, if the discontinuity is like this, then we are going to insert as per rule perpendicular normal to the extension of the discontinuity, not inclined in discontinuity, because if we are going to put theta is a 90 as a normal, then we are getting maximum sigma B, which is stress in bolt. Means the load coming on the discontinuity discontinuous material is going to sustain by the bolt. Same thing. If we are going to see any discontinuous or any jointed rock mass, then this jointed rock mass, due to presence of the joint J1, J1 or J2 others, there is a three type of movement we can encounter. One is a separation, another is a closing, another is a translation. You can see separation, this block. Suppose this is the joint plane, block A, block B. So block A is moving down, then there is a separation. If block B is moving toward each other, then there is a closing. And translation, if this block is moving, then leaving some space. In case of separation, in case of this type of profile of this joint, when we are going to displace this, then we are getting to separation also and translation also. Closing also going to show some linear separation or closing and some translational movement. Following this bolt is going to enhance two components. One is tensile strength of jointed or joints. Joints means jointed rock or rock mass. Another shear strength of joints or rock mass. Following different criteria, you can see here the enhancement in tensile strength of joint can be formulated at sigma b stress developed in bolt and multiplied by the cross sectional area of bolt. In this way, we are going to get the shear strength, are going to get the increment in shear strength of joint. Where the sigma b we have already discussed can be calculated by putting this value. You can see here when we are going to insert this bolt at incline, then due to separation there is a tilting of this and not going to show any resistance. So tensile strength we can calculate. However, the shear resistance due to joint, the reinforcement due to axial response of bolt is responsible in form of frictional component and shear component, and another reinforcement due to shear response of bolt, that is also known as Dowell effect. So in brief, here we are going to about the axial response. We can see the development of the normal stress and shear stress by simply number of bolts into the stress developed in axial and stress developed in axial response of the bolt. The N can be calculated as ratio of AB by AN, and following the Hamilton rule given by Boughton and Torve in 1964, where this tau by the sigma A is a tan phi, and finally we are going to calculate the resistance, total resistance offered by the rock bolt in brief, where this shear response of bolt can be calculated by applying this tau Rs is equal to tau S cos theta. The shear response contribution should always be taken into account, and the shear response of mechanically anchored rock bolt come into existence after certain amount of displacement can take place, since space between the bar and bore holes are more. The total shear response of rock bolts along with the tensile response depends on character of axial stress in bolt, the installation angle and the type and dimension of bolts. Now we are able to calculate the number of bolts by applying this concept. N is equal to Q by SF, where the Q is a function of unit weight of rock, then the span of opening, then the height of opening. If we are going to create this type of opening here, or simply rectangular opening will be more suitable to explain. We are going to create this opening, then there is a development of loosening zone. We are going to insert bolt to suspend this type of rod. By fixing this bolt, in intact zone. So how many numbers of bolts are required to suspend this type of detached mass of the detached zone? We can calculate based on the span of opening, this B, this H is the not opening, the H is the height of loosening zone, and this gamma is unit weight of this material. Then this sigma y is the yield strength of bolt or yield ultimate strength of bolt. In this way we can calculate the number of bolt by determining the Q value, and this Q value is a function of unit weight of rock, then width of span, and the height of the loosening zone or damage zone, which we are going to restore in its original position. In this way we are going to provide the support by using rock bolts. And why we are going to use this perpendicular? Because when we are going to put the theta is 90 degree, we are getting the maximum tensile resistance beared by this, and this becomes success after sufficient strength of intact zone and the yield strength of steel bar and this amount of this loosening of the friction and others. In addition to this, we are going to calculate about the length of bolt. The length of bolt, you can see the length of bolt should be more than this loosening zone. So therefore this part we are going to divide in two zones. This is the length of intact zone and this is the length of loosening zone. So these two we are going to add LA plus L loose. For a particular opening, for pre-tensioned rock bolts in roof of the opening, we have calculated based on the support system. L is equal to 2 plus 0.15 into B divided by ESR. In case of the walls, the same thing, L is equal to 2 plus 0.15 into H divided by ESR, where ESR is representing excavated support ratio. H is the height of opening wall in meter and the B is the span of. In case of soft, we are also having some relationship because soft is a vertical opening. So L is equal to 0.35 B by ESR. Friends, this material for lecture I have collected from the book written by Bhavani Singh and R.K. Goyal on tunneling in weak rocks, published by LJBR and published by Geoengineering book series, edited by a great professor, Professor John A. Hudson from Imperial College London. Then partial support from the paper written by Goodman Ari and the Shai G in 1985 regarding the block theory and its application in rock engineering, and then about book written by Satyanarayan Bhutkuri and the Katsuyama in 1994 on Introduction to the Rock Mechanics, Industrial Publication Consulting Inc. and in Tokyo, ranging from page 1 to 272. Here we are going to conclude that unified approach is principally involving the structural defect and rock support interaction approach. According to this concept, there is a formation of different zones, namely zone formed by structural defect, loosening zone, and then plastic flow zone, then the plastic hardening zone, and ultimately in last we are having elastic zone, that is our original ground. It indicates that the elastic zone is the boundary where there is no influence of the excavation induced stresses effective. As for unified approach, the three kinds of zones form basically, and we are going to add one plastic hardening zone. The commonly used support members are steel and concrete liners, shotcrete reefs, rock bolt and others, girders and others, but commonly we are using these support system. The rock bolt principally work on the principle of suspension effect, where we are going to suspend the loose rock mass to restore the damaged zone to its original position in tune of the already intact rock present in strata. And for this we are able to calculate the number of bolts and distribution of bolt by fixing and considering the diameter of bolts and others, then the length of bolt in different situations, located in roof, located in wall, located in horizontal tunnel or located in vertical shafts. Dear friends, in this class we have elaborated about concept of structural defect approach and unified approach and rock support in integrated manner, then about how the rock bolt is going to enhance the tensile resistance and shear resistance of this continuous media or rock mass present in damage zone are caused due to excavation of opening induced stresses. And then we have concept regarding the calculation concerned to number of bolts, length of bolt to support created opening or some surface structure. Thank you very much.